Okay, so now in Chapter 6, we're going to be starting the second type of statistics known as inferential statistics. Recall from the very first day of class, there was two types of statistics, descriptive statistics and inferential statistics. Inferential statistics uses sample data to draw conclusions about the population. There are two main types that we'll be looking at, confidence intervals and hypothesis testing. In Chapter 6, we're going to be dealing with confidence intervals, and confidence intervals are used to estimate unknown population parameters. And in hypothesis testing, we're going to be testing whether a population parameter has changed or comparing population parameters. And we'll be doing hypothesis testing from Chapter 7 on. Now, estimation theory uses sample data to estimate an unknown population parameter. So we may use the sample mean to estimate the population mean, use the sample standard deviation to estimate the population standard deviation, and use the sample proportion to estimate the population proportion. Remember, these population parameters are unknown, but we can always find a sample statistic by just taking a sample and calculating the statistic. Now, confidence intervals are what we're going to use to estimate this unknown population parameter. It consists of three components: the point estimate, which is the sample statistic, a margin of error, because we're not saying that the population parameter is exactly equal to the sample statistic, but that it's within a certain margin of error of this sample statistic. And then we have the confidence interval, which incorporates that point estimate plus or minus this margin of error. So first concept, the point estimate. It is a value or point used to approximate a population parameter. Examples are, for the sample, we're going to use the sample mean to estimate the population mean. We're going to use the sample proportion of successes, p hat, to estimate the population proportion of successes, p. So true or false, point estimates are a very good way of estimating population parameters because samples do not vary from the population. Let's take a minute, stop, and think about this for a second. And do you think this statement is true or false? False, because the point estimate, every time we take a sample, we're going to get a different sample statistic. So it is not, we think it's a starting point, but we do not think it's exactly equal to the population parameter. Now, confidence intervals are what we're going to use, and it's a range of values. It's going to say, I think the population parameter, which I do not know, is somewhere within this range of values. The range of values is what we call this interval. It's also called the interval estimate, and we often abbreviate it by CI for confidence interval. The confidence level, now also with our interval is a level of confidence that we assign to this. How confident are we that the population parameter falls within this range of values? The confidence level is usually calculated by 1 minus alpha, and it's often expressed as a percentage value. And it is the proportion of times that the confidence interval actually does contain the population parameter. It assumes that this estimation process is repeated a large number of times. The most common confidence levels are 90%, 95%, and 99%. So what this says is if I did this procedure 100 times and I was doing 95% confidence intervals, I would assume that 95% of them would contain the true population proportion, the true population parameter, but 5% would not. And so I'm kind of assuming that, I'm hoping that my confidence interval is one of the 95 that does contain the population parameter, not one of the 5% that does not. It's also sometimes known as degree of confidence or the confidence coefficient. Now, we have another idea known as critical value, and critical values are sampling distributions are often approximated, well, the sample proportions definitely are approximated by the normal distribution under certain circumstances. And those circumstances are going to be given in just a minute. And the sample proportions have a relatively small chance of being extreme, meaning falling into these tails of size alpha over 2. If we place 2 tails on our normal distribution, what we're saying is we think the population proportion is in the center, not in these 2 tails. So we're going to have to calculate something known as a critical value, the z-score that separates the right and left tail region is denoted by z of alpha over 2. That's the value that separates the right tail, and minus z of alpha over 2 separates the left tail. Okay, so we can do this with Minitab or with our standard normal table. And the lower boundary is separated by negative z of alpha over 2, and the right boundary is separated by positive z of alpha over 2. So these critical values are on this borderline, and we can find them using either the tables or Minitab to find these values that separate what's known as the tails of the normal distribution. So let's see how we find a critical value that corresponds to a confidence level of 99%. All right, so we're going to use Minitab because in this class we like to use Minitab. Calc probability distributions. Now this is a critical value. Remember, when you're looking for values, you do inverse cumulative probability. You're going to find these tails. You're going to find, let's find the left, the critical value for the left tail first, and that's 1 minus 0.99 divided by 2, and that's equal to 0.005. So we enter that into the input constant, and we're going to get, Minitab tells us negative 2.575, but the critical values are plus or minus 2.575. That's what corresponds to a confidence level of 99%. Now, confidence intervals for proportion are the first confidence intervals that we are going to investigate, and these conditions must hold. First, our samples must be simple, random samples. Hold on just a minute, I'm going to pause the... Okay, so sorry about that. My computer was getting low. All right, back to the conditions. Besides the samples being simple random samples, the binomial conditions must hold. Remember, there was 4 conditions for the binomial condition to hold. If you need to review them, remember they were in chapter 4, 4.3 contained the conditions for binomial conditions. And this is the condition when proportion will estimate the normal distribution. We need to have n times p hat, and p hat is equal to the number of successes divided by n, and n times q hat, and q hat is 1 minus p hat. Both of these values have to be greater than or equal to 5 for the normal condition to hold and for the formulas I'm giving you to hold. Now we need to find, p hat will be our sample statistic, our point estimate. So we can always find the sample proportion by just taking a sample, counting the number of successes in that sample divided by this total sample size, and we get p hat, or the sample proportion. Now remember, our confidence interval is that sample proportion plus or minus some interval, to get some interval. We get that interval by calculating the margin of error. All right, so the margin of error is the difference from the observed sample p hat and the true value of the population proportion. It's also sometimes called the maximum error of our estimate. Now we're starting our estimate with the sample proportion, then we're going to find this interval or range of values that we think the true population proportion is. Now remember, we don't know what it is, but we think it's within this range of values that we're going to calculate using the margin of error. The formula for the margin of error is this critical value that, remember, for 99%, it was 2.575. P hat times Q hat divided by N, and you square root this value. And then our confidence interval is going to be that sample proportion P hat minus the margin of error will give us the lower limit for this range of values, and P hat plus the margin of error will give us the upper value for this range of values that we think the true population proportion falls within. All right, so I'm going to show you how to use Minitab, which is really the way we're going, which is much easier. But let's see if you understand how the formula works. Suppose we have a sample of 800, and out of the 800 we had 200 successes. Find the margin of error for a 95% confidence interval using the formula you just saw a few slides ago. Pause the PowerPoint for just a minute. Try to calculate that with a calculator by hand and see what you get. Did you get 0.030? I hope so. So now let's find the left endpoint, the lower value for this range of values, using the formula that I gave you a couple slides ago. Pause the PowerPoint for just a minute. Try to find the lower value, which is also known as the left endpoint of the confidence interval. Did you get 0.22? I hope so, because then you know you're using the formula correctly. Now, it is much easier to do Minitab to find these confidence intervals, because Minitab is going to do all those formulas for you. So let's see how we use Minitab to find confidence intervals. You go to Stat, then Basic Stat, and then a whole bunch of choices will come up. We're going to go to where it says 1 sample P. A box will come up. You're going to enter in X, which is the number of successes, into the number of events, and you're going to enter in your sample size. Then you're going to click Options, and as long as those conditions held, you're going to check the box to use the normal probability. Right? Then you select the appropriate confidence level. Remember, this is the only time that you don't enter in 95% as 0.95. You enter it in as actual 95. Be sure that the alternative is set to not equal. And then you just click OK, and Minitab will give you the confidence interval. So let's try an example. This is Chapter 6, Section 2, Finding Confidence Intervals for Estimating the Population Proportion. And this is number 17 in the problem set. And they're asking us to find the margin of error and the 95% confidence interval. They tell us the sample size is 400 and the number of successes is 300. So you do Stat, Basic Stat, 1 proportion. Enter in your number of events, which is 300, and your sample size, which is 400. Go to the Options box. Make sure you check the box that says Use Interval Based on Normal Distribution. Select your confidence level to be 95. Now pause this PowerPoint for just a minute. Go to Minitab and enter all this in and see what Minitab tells you the confidence interval is. Okay, so I hope all of you got this. Minitab gave you this answer for your confidence interval. Now notice, even though if you're doing it by hand, you would find the margin of error first, but if you're using Minitab, it's easier to find your confidence interval first. And then use this other formula. The margin of error is equal to the upper limit minus the lower limit divided by 2. So 0.7924 minus 0.7076 divided by 2 is 0.0424. That is your margin of error. Much easier than doing all the formulas by hand, but it's important to understand how this theory works. So we look at the formulas, but we're going to actually do all of our problems using Minitab. Now sometimes we have a given margin of error. We know that we need to have our estimate to be within a certain margin of error. So if we want to find the sample size for estimating P, if our sample proportion is known, we use this formula, but this means we know P hat and Q hat. If we do not know it, then we assume P hat is 0.5 and Q hat is 0.5, and 0.5 times 0.5 is 0.25. you would use this formula. All right, so note sample sizes, though, must be integers. You have to have 10 people in your sample or 11 people in your sample. There's no such thing as having 10.5 people in a sample. So you always round up your minimum sample size. All right, so now let's see if you understand how that formula works. Now, this formula is not done by Minitab, so you actually do need to do this with a calculator to calculate the minimum sample size. All right, so we have a margin of error of 0.05. We have a confidence level of 95%. You need to go find the critical value for a 95% confidence level. And suppose it's known from a previous study that p hat is 18.5%. Now, our formula p hat needs to be changed from a percentage to a decimal to use the formula we had a couple slides ago. So pause the PowerPoint for a minute, put those numbers into that formula, and see if you get the correct answer. Did you get 232? Remember, you had to round up. No matter what, even if you had 231.1, you do not use rounding rules. You always round up. If you need 0.1 of a person, you need a whole other person in there. All right, so that is the end of section 6.2. We're going to stop this lecture now and pick up again in section 6.3, where we'll be estimating, doing confidence intervals to estimate the population mean.